So in this video, we're going to finish off this arrays note sheet. And then after that, we'll be ready to start our next program. So get out this packet that you should have halfway finished. We did pages 1 through 3 on the last video. So we talked about arrays, how it's a group of data of the same type that appears together. So it's one data type, ints or doubles or whatever, that can hold multiple values. We talked about how to declare arrays. So if we want to make it so it's not initialized to anything, so it's initially empty, it would be the type, bracket, bracket makes an array, the name of it, and then the word new always, and the type again, and then in here is the size of the array. And remember that the arrays go from space 1, the first space is always 0, so the last space will be 1 less than whatever you say the size is. So we did some work with initializing it, talking about how to put numbers in the arrays, and we ended with the idea of swapping and how to fill an array from a file. Okay, so now we're on page 4, and the first thing that we're asked to do is to write a method to print all non-negative values in an array of integers. Okay, so most time when you're printing, it's going to be a public void, and that's what this one is. So start with public void. And let's just call it print nums. And we need to give it the array of integers that we want to print from. So that's our parameter, int bracket bracket a. And since we're writing a full out method now, let's do the pre and post conditions just to always be in the habit of that. So for this one, the precondition would be an array of integers. And our post condition is that it prints the non-negative values in the array. Now notice the post condition isn't none, and I talked about that when we did pre and post in the last set of notes. Post condition is really never going to be num. Just because it's a public void doesn't mean the method doesn't do anything. So the post condition is still supposed to describe what the method does. So think about what we need to do here. Basically, we need to go through this integer array, and we need to check if the current value is not negative, and if it isn't not negative, we want to print it out. So anytime you're going through an array, you need to train yourself to think about using a for loop, because that's what a for loop can be used for. We can get to every index in the array by using those I values. So that's what we're going to start with. And if you remember from last video, if I'm using a for loop to go through an array, what should I start I at? I should start it at 0, because the first value in the array, the first space, is index 0. We're going to go as long as I is less than. Remember how to say how long the array is? You take the array name, which is a, and say a.length. And it's strictly less than, because remember, if it's of length 5, we would need I to go from space 0 to 4. So we don't want less than or equal to. No parentheses. There's only double parentheses if a was a string. And then I++. Okay, so we only want to print out the non-negative numbers. So how do I check if something's non-negative? Well, I would say if the spot I'm looking at, which is a bracket I, so the value stored in the current index spot, if that's non-negative, which means if it's greater than or equal to 0, then we want to print it out. So we'll have a system.out.print. And you might as well do print ln. And I want to print the number that's in that spot. So that would be the array a at spot I. So we'd write a bracket I. And that's it. End of the if statement, end of the for loop, end of the method. Okay, so hopefully that wasn't too terrible of a one to start out with. Number 3, underneath it, write a method which will return the number of times a given integer appears in an array of integers. So think about what you would need to do. You would want to, you have your filled integer array, so there's our parameter again. It's returning the number of times, so it's not a public void anymore. It's going to be a public what? Right, it's going to be a public int, because it's going to be a number of times. So we're going to need an accumulator to count up how many times a given integer appears. So we're going to have to give it the array and a certain integer to look for. All right, I think we're ready to write it. So let's start with public int, because it's returning the number of times, which is a frequency, so I called it frequency. And we need to give it the array, so int bracket bracket a. And you also need a number to look for. So I'm going to call that int num. Okay, so next up is our pre and post conditions. We've got two parameters to describe this time. We have an integer array and an int. Really, it's an int that we're searching for. So I guess we should say an int to search for if we want to really be descriptive of it. And the post condition is that it returns the number of times the int appears in the array. Number of times the int occurs in the array. Okay, so I kind of spoke about what we want to do. We want to have an accumulator that's going to go through the array, and if the current spot equals the number I'm looking for, I just want to add one to the accumulator. So let's start with an accumulator. I called it int freq. And initially, since this is counting the number of times, if it never occurs, we want it to equal 0. So set it equal to 0 to begin with. And now what am I going to use to go through every spot and check every spot in the array? Obviously a for loop. And what do we start array for loops at almost every time? Int I equals 0. Got the I here. As long as I is less than a dot length, because the array name is still a, less than because it goes from 0 to 1 less than the size, I plus plus. And this time I'm checking if the current spot, so if I want to look at the value in the current spot, that's if a bracket I. If that's equal, so double equals, because I'm checking the number I told it to search for, so num. If that's true, what do we want to do? We're not printing out any time, I'm adding one to the frequency. So I'm just taking freq. I can say freq plus plus, or I could say freq plus equals 1, either way. And the if and the for, but at the end, remember you have to return the number of times. It's a public int this time. So we're going to return freq. Okay, so what do you think about that? Does that make sense? Now's a good time to ask for questions. So if you have any, pause the video and call me over, or if you're watching it outside of class, write a note in the margin and I'll answer it for you the next time I see you. Before we go on though, let's talk about how I would use this method in a program. So presumably this method that we just wrote would be written in some other class. So let's even, I'll put a public class outside of it here. I know you're all mad that I'm adding something and you're trying to squeeze it in. Sorry. I'm just going to call it public class, the class. Okay, so now that method is written in some class somewhere. And presumably I have some driver or some other program that's going to access this class. So I'm just going to carve out a spot to right over here. So in the driver or something, I have to make an instance of this class if I want to use this method. So I'd say something like the class C1 equals new the class. And let's make an int array in this class. So I'm going to say int bracket bracket. I'm going to call my array ARR over here. And I'm going to initialize it too. So remember, we can also do an initializer list. I showed you this in the last video. We're going to put a 2, a 4, a 6, a 2, a 3, and a 2 in this array. Okay, so we haven't really talked about how the computer deals with that. But what just happened is the computer carved a memory location, and they called it ARR. And that's actually a pointer. And you'll learn more about pointers in AP Comp Sci. But it's essentially pointing to a spot in the computer's memory where these values are all stored. And the array that you should be picturing in your head would look like this: 2, 4, 6, 2, 3, 2. And if I wanted to use this method, let's say I want to print out how many times 2 occurs. I could say system.out.print. The number of 2's is, this is going to be words, I'm going to put it in quotes. And then I'd have to end the quotes because that's the end of my words. But I'd want to print whatever variable is returned by this method, frequency. And that's a method in the class, so that's C1. So if I want to use that, I'd have to do C1.frequency. And remember, you need to send it 2 arguments. You got to send it the array and the number you're searching for. So in the class or in the driver, the array that I'm sending it is called ARR. And the number I'm searching for is 2. And that's how you would use the method. Because remember, you have to do something with methods that returned. So the frequency, in this case, 2 occurs 3 times. So 3 is going to get returned to this spot, which is going to make it part of this system.out.print. And the output's going to say the number of 2's is 3. Okay, so that's just a little bit of an idea of what an array actually is. Again, technically it's called a pointer, which is a variable with name that points to a spot in the computer's memory. But what you really should just picture is like this almost file drawer of numbers, and each drawer holds a different number. All right, let's go on. Number 4. Write a method that will find and return the largest value in an integer array. So I have a star on this page that says histogram. And I'm not exactly sure what that means, but I know that histogram is your next program. So there's probably a good chance that this method is integral to be used in that next program. Okay, so again, we're supposed to write a method that will find and return the largest value in an integer array. So find and return. So it's returning an integer, a value in an integer array. So it's returning an integer. So we're definitely going to have a public int. What do you want to call it? Largest sounds good to me. And you think you need any information? Well, you need an array to search for. So int bracket bracket a needs to be given. Okay, so now our precondition would be an integer array. And the postcondition would be returns the biggest value in the array. Okay, so I'm going to kind of try to talk you through it as I write it, but then I'll show you an example why it works. we need something to hold what the largest value is. So int largest equals, and initially we're going to set it equal to the first value in the array, so a bracket 0. We're basically going to compare this number to every other value and see if it finds something bigger. If it does find something that's bigger than what we're saying is the largest, that becomes the largest. If it's not bigger, we're just going to leave this the largest. So basically I have to go through the array. So as always, for int I equals 0, I is less than a dot length, I plus plus. So we're going through the array. At every spot in the array, I want to check if the current value is bigger than the value we're calling the largest. So that's going to look like if a bracket I, the current value, if that's larger or bigger than what we're saying is largest, then that means what we said was largest isn't the largest, and a bracket I might be. So we need to reset largest to a bracket I. And it's going to do that with every spot. So now that spot's the largest, but if it finds something bigger, it'll change that again later. And that's really all there is other than returning the largest. Like I said, this is a method that's going to come up in histogram, but it's also going to come up a lot more in Comp Sci 2, so it's really important that you understand it. So let me run you through an example of how this actually works. You can see that it works, and if you still have questions, obviously call me over and ask me. So let's say I have this array. We have 2, -5, 57, 17, 42, and 3. Now in your head, you've probably already figured out that the largest is 57. But how you did that, because you didn't know what the largest was going to be as I was writing, initially when I just had a 2, 2 was the largest to you. So initially in this method, largest gets set to a bracket 0, which is 2. Now then if you notice, the for loop starts at 0. So the first time it's comparing a bracket 0, which is 2, to largest, which we're also saying is 2. I don't technically need to compare it to itself, so I could really start this with I equals 1. But one time through a loop to a computer isn't a big deal, so it doesn't really matter either way. But anyways, once I is 1, a bracket 1 is -5. Is that bigger than largest? Nope. So this doesn't happen, and there's no else, so all that happens is I becomes 2. Now a bracket I is 57. Is 57 greater than the largest? It sure is. So largest becomes a bracket 2. So largest is now 57. And I becomes 3. Is 17, a bracket 3, bigger than 57? Nope, so nothing happens. I becomes 4. Is a bracket 4, which is 42, bigger than largest? Nope, nothing happens. I becomes 5. Is a bracket 5, which is 3, bigger than largest? Nothing, nope, so nothing happens. For loop isn't less, I isn't less than a dot length anymore. There's nothing else to check, so we return the largest value. We return 57. Okay, so you can see hopefully that it does work. And what you're really doing when you're coding is you're trying to put into words the process your brain follows step by step. And step by step, what you do is you start with the first number, you compare it to every other number until you find something bigger, and then you compare that number to everything else until you get to the end. It's exactly what your brain does. Okay, now down here, number 5 is closely related. Write a method that will find and return the position of now we're looking for smallest value in an integer array. So if I just said return the smallest value in an array, it'd be the exact same code, except this would be a less than sign instead of a greater sign. But the fact that I don't want the actual value and I want the position of the value adds a small wrinkle to it as well. Okay, so let's get writing. It's going to be public int smallest. And just like last time, we need to be given the integer array. So int bracket bracket a. And precondition is just an integer array. And our post condition is what the method does, and it returns the position of the smallest number in the array. Position being the key word here. And I think you will need this this method for that histogram program as well. Okay, so we're going to start off very similar. We're going to have a variable called int smallest instead of largest. And just like last time, I'm going to initialize that to the first value in the array, a bracket 0. But what I also need to keep track of is where the position of that smallest value is. So I'm going to also put a second variable called int small position. I'm just going to abbreviate position POS. And the position that I'm saying the smallest is at initially is position 0, so it makes sense to start that at 0. Okay, now I need to go through the array. So I make a for loop. And just like I mentioned up top, I don't technically have to compare this to itself. I don't need to compare smallest to a bracket 0 because it already is a bracket 0. So if you want to start this at 1, you can. If you want to start at 0, makes no difference. It'll still work. I is less than a dot length. I plus plus. Like I said, the theory and process is basically the same. So now I'm checking if the current spot I'm looking at, if a bracket I, if that's smaller or less than what I'm saying smallest is, then I found a new smallest. So I want to set smallest equal to a bracket I. But I also need to update where that small position is. So what do you think I want small position to equal? Right. I know you must be saying I. I is where the position of the value of the smallest is currently stored. So then in the end here, what do we want to return? Well, I care about the position. We only use smallest to find it. So it returns, oops, only one, not plural on returns here. So return small position. So now that'll show us where the smallest value in the array is. All right, if there's any questions on either of the ones on this page, make a note or call me over. But if you're good to go on, let's do the last one. Okay, number 6. Write a method that will find and return the second largest value in an integer array. Okay, so it's finding and returning, so let's get the easy part out of the way here. We know it's going to be a public int again. And we'll call it public int second largest. And we need an array to search, so int bracket bracket a must be the parameter that's given to us. Pre and post conditions should be pretty straightforward. The precondition again is an integer array. And the post condition is that it returns the second largest value in the array. think about it for a second. In order to find the second largest value, you also would need to know what the largest value is, right? Okay, so we need two variables to keep track of. We need int largest and second largest. Both of those are going to be ints, so I can put those together. Okay, there we go. So I can't just set largest equal to a bracket 0 and second largest equal to a bracket 1, because I got to know at least which of those two is bigger. So let's at least figure that out first so we can initialize these. If the first spot, a bracket 0, if that's bigger than a bracket 1, then at least between those first two spaces, we can say largest is a bracket 0, and second largest is a bracket 1. I don't know what comes after that, but at least for the first two elements, that's true. Otherwise, it's got to be the other way around. So otherwise, largest must be a bracket 1, and second largest must be a bracket 0. Okay, so now I've at least got those initialized. Now what we're going to have to do is we're going to have to look through the rest of the array, see if the number I'm current spot is bigger than largest. That would bump my old largest down to second largest, and I'd have a new value for largest. Or I also have to check if the value I'm looking at is bigger than what I'm saying the second largest is, because I would just bump out second largest, and largest would stay the same. So we got to check this order. So we first got to go through the array. So we have a for loop. What do you think we could start I at? Well, since we've already kind of figured out between position 0 and position 1, what's the largest and what's the second largest, first one I really need to compare would be at position 2. As long as I is less than a dot length, I plus plus, and I want to say if I found a new largest, so if a bracket I is greater than what I'm saying largest is, then I don't care what I used to say second largest is, that's gone. My old largest gets bumped down to second largest. That's got to happen first. So let's set second largest equal to whatever our old largest was. And the actual largest is now whatever is in a bracket I. Okay? That's if I found a new biggest value. There's an else if though. So else if, so if a bracket I isn't bigger than largest, but if it is bigger than second largest, then my largest doesn't change, but my second largest becomes a bracket I. And that'll only happen if we already checked that it wasn't bigger than the largest. If it's not one of those two cases, we don't want to do anything. We'll just keep everything the same. So that's the end of our for loop. And all I have to do is return second largest. And there you have it. So if you've got any questions, please, again, make sure you get those answered. The next video will be some multiple choice questions with arrays. So some practice on just getting the feel of how those work.